Hi, ladies and gentlemen. We're going to go over some of the hard molarity and molality problems. We're going to start with solutions. You can do it, okay? You can, absolutely. Here's the deal. I am armed with a periodic table. I have a calculator, and I have a Coca-Cola. And after that, I can do anything. So here we go. Let's try our first. So first we have a 1.64 molar solution of silver nitrate, and it has a density of 2.92 grams per milliliter. What is the molality of this solution? Okay, so generally when we get into a place like this, okay, we have to know what molality is. So molality equals moles of solute over kilograms of solvent, okay? Now, here's the deal, ladies and gentlemen. We already know moles of solute. You're thinking, how do I know that? It says 1.64 molar. But really, that's the same as saying 1.64 moles equals 1 liter. Okay? That's all that is. It's moles per liter. So since I already know the number of moles, the top is taken care of here. So this is done. Now I have to figure out kilograms of solvent. So this is where we have to do a couple calculations. And the big deal is that we know the mass of the solution equals the mass of the solute plus the solvent. So what I'm going to do first is I'm going to figure out the mass of the solution. And I'm going to use density. Density equals mass over volume. So we know we have 2.92, okay, is our density. And we don't know the mass, so I'm going to call that X, but we do know the volume of the solution. It's 1 liter. I need to take that out of liters because the density is in milliliters, so I'm going to put 1,000. So right there, I can find X really simply. I just do 1,000 times 2.92, and I end up with, this is crazy, X equals 2,920 grams. Okay? So now I have found the solution. Can I find the solute? Absolutely. Here's where we go with solute. So now we know that we have 1.64 moles AgNO3. I can take that to grams simple. I can just do a simple mole conversion. 1 mole of silver nitrate. I would then look on my PT and say, silver is 107.87, nitrogen's 14.01, oxygen's 16. I do the math. I end up with 169.88 grams. And when I do that, it comes out to 278.6 grams of silver nitrate. So now I have 2 different grams. Can I figure out the grams of the solvent now? Okay, I sure can. I can take 2,920 equals 278.6 plus X. And I end up getting X to equal 2641.4 grams. Now I'm going to move this slide over, okay? So now we have a blank page. What I am sitting at here is I have 2,641.4 grams of solvent. Now I just have to move it over to kilograms, 1,000 grams, and 1 kg, and I end up getting 2.6414, and I leave all those numbers till the very end. Kilograms, okay, solvent. And from before, I knew how many moles. My number of moles was 1.64 moles. So now, in order to do molality, I end up with 1.64 divided by 2.6414, and I end up getting this beautiful number of 0.621. I did it down to 3 sig figs, molal AgNO3. So ladies and gentlemen, that is that type of question. So let's move on to the next one and see how we do. Alrighty, now we have this big mass, volume, and density. Find molarity and molality. One of them is always easier, and that's generally molarity. So what I'm going to do here with molarity is I'm going to start with molarity is moles over liters. And I can figure out the number of moles here because they told me this grams. So all I'm going to do is I'm going to take 75.4 grams CuSO4 and I'm going to take it over 2 moles. I know that 1 mole CuSO4, okay, has a molar mass of 159.62 grams, and I come up with 0.472 mole. Okay, and I have that 0.472 mole. That's awesome. Now can I figure out the liters? Well, I do know I have 732 milliliters, so I know that that is 0.732 liters. So now all I just have to do is 0.472 divided by 0.732, and I end up with 0.645 molar. All right, so there's our molarity. Now let's deal with molality. Let's do that on the. All right, so now we're going to just focus on molality. Molality, okay, is moles over kilogram solvent. Okay, so we have this big situation where we know the moles. We already kind of got that. We know it's going to be 0.472 moles. We did that in the last problem. Now we just have to figure out this kilogram. So this brings us back to the whole solution thing, okay? Solution equals solute plus solvent. Okay? Now, we already know the mass of solute. The mass of solute was given at the beginning of the problem. It was 75.4 grams. We need to figure this bad boy out. And the way to do it is using density, okay? Density equals mass over volume. Okay, we know from the problem the density is 1.34. We also know the volume was 732 milliliters, so we can find x. So our x equals 980.88 grams. I just did that math. Okay, if I subtract 75.4 grams, I end up with the mass of solvent. And I ended up with, this number is 905.48 grams. I have to move that, change that over to kilograms, so it's 0.90548. Okay, and now I have moles, which I have up here, up at the top. So molality equals 0.472 divided by this kilograms off to the side, 0.90548, and I end up getting 0.521 molal. That's all we have to do. Now these are tricky, but hopefully you're getting kind of the idea. All right, let's see what the next one is. All right, so now we have a percent and we have to do density. Now here's the deal. I think this is the hardest one we can do, but I think we can handle it. The first thing we got to do every time we see a percent is take it out and go. It's 78.5 grams solute, okay, in 100 grams of solution. Okay, so that's the first thing we have to do. 78 that's what it is. And then it says, if it is 9.25 molal, what is the density of this solution? Well, the deal is that we need to figure out the actual volume is where we actually need to figure out, because we have all these masses, okay? We have mass of solution, we have mass of solute, but I don't see any volume. So we have to use this 9.25 molar. So I have to use 9.25 equals moles over liters. Now liters is what we're looking for, okay? But mole we don't know. The way we figure out mole is we take our 78.5 grams of Na2SO4. And once we have that, okay, I'm going to do not 1 mole, excuse me, I was going to put 1 mole down there. 1 mole equals 142.07 grams. That's the molar mass, and I figure out the number of moles. I ended up getting 0.5525. So now I can put that number up here for moles. Now when I do that, it comes up to 9.25 equals 0.5525 over liters. So I end up getting liters equals 0.0597. Okay? And that's going to be in liters. And now density is just mass of the whole solution over the volume of the solution. Well, the mass is 100 from up here, okay? Divide it by this volume. I changed this volume to milliliters, which would just be 123.597, or excuse me, that should not be a point. It should be 0.597 or 59.7 milliliters. And I end up getting 1.6. And how many sig figs do we have here? 3. So 1.68 grams per ml. There you go. There is your percent to density. It's kind of a pain because sometimes you want to start with this and maybe use that, but don't. You want to use for solution, okay? You're always looking at the solution. So, ladies and gentlemen, let's try our new. Alright, ladies and gentlemen, now mole fraction, okay, also has this nice little 75%. So what that means is we have 75 grams sulfurous, which is H2SO3, because I learned how to name acids earlier, in 100 grams of solution. What that also means is we know then how much water, 100 minus 75, equals 25 grams of water. That's important because mole fraction is the number of moles of one thing, in this case H2SO3, over the number of moles of H2SO3 plus the moles of everything else. In this case, it would be water. So we got to add and figure out some moles. So we literally take 75 grams H2SO3 and go to the periodic table, look up our molar mass. It's 82.09 grams in 1 mole. And I ended up with 0.9136 moles H2SO3. And then I have to do the same for water, 25 grams of water. Okay, and there's 18.02 grams of water in 1 mole. Then I end up with 1.387 moles of water. Now I just have to do the math. 0.9136 divided by 0.9136 plus 1.387. And I end up with a number. I get 2 sig figs, so I'm going to say 2.4. And there's no unit to it. It's pretty sweet. Awesome. I hope this nice little recording has helped you out and gives you some aid when you're doing these harder problems. Have a good day.